Imagine living on a planet where your biggest worry is paying taxes, then learning that at any random moment, the sky could send a death beam so powerful it would make every nuclear weapon on Earth look like a tea candle. That is what gamma ray bursts are. They are the universe's way of flexing its muscles, and those muscles are violent. These are the most energetic explosions we know of, second only to the Big Bang itself. To put that in perspective, one of these cosmic tantrums can release more energy in a matter of seconds than our sun will emit across its entire 10 billion year lifespan. Think about that the next time you get sunburned and feel like the star at the center of the solar system is too much. That overachiever is nothing compared to these things. Gamma ray bursts, or GRBs, for the acronym enthusiasts, were discovered almost by accident in 1967. The United States had launched satellites to spy on secret nuclear tests. Instead of catching the Soviets being sneaky, the satellites picked up flashes of radiation that came from space. That is like trying to eavesdrop on your neighbor and accidentally intercepting a call from aliens. Scientists eventually realized that these mysterious spikes were not bombs, but something stranger. The universe was producing explosions so intense they made nuclear blasts look like toys. It took decades to even start sorting out what was happening. Now we know that GRBs come in two flavors. The first type is short bursts, which last under 2 seconds. These are born when two neutron stars crash into each other. A neutron star is already one of the densest objects around, a sun crushed into the size of a city. So when two of them slam together, the result is cosmic carnage. The collision creates a black hole and a burst of gamma rays. This theory was not just speculation either. In 2017, astronomers detected gravitational waves from colliding neutron stars at the same time as a short GRB. That was like watching the crime scene and catching the culprit in the act. Mystery solved. The other type is long bursts, which can last from a few seconds to several minutes. These happen when a massive star reaches the end of its life and collapses. Instead of going gently into the dark, the star funnels its death throes into twin jets of radiation that blast through space at nearly the speed of light. If one of those jets happens to be pointed at Earth, congratulations. You have front row seats to the ultimate cosmic laser show, and you're also cooked. Luckily, the odds of that happening to us are low, but not zero, which is both comforting and terrifying at the same time. Most GRBs are weird enough on their own, but some cases stand out as especially baffling. Take GRB 2220627A in 2022. This one lasted almost 17 minutes, an eternity compared to typical bursts. Even stranger, it produced two separate gamma ray flashes. Astronomers think gravitational lensing might have been involved, where massive objects bend light and produce duplicates. But the data did not quite match up with that explanation. It was like seeing lightning strike twice in the same spot, but with different thunderclaps. The universe clearly didn't read the manual on how these things are supposed to behave. And then there was the so-called boat, the brightest of all time. Also in 2022, this monster lasted about 7 minutes and was so powerful, it temporarily blinded satellites. Imagine building advanced instruments to study space only for the universe to hand you an explosion so bright, your cameras basically scream in pain. The boat was so intense that it even disturbed Earth's ionosphere. That is the upper layer of our atmosphere, which normally shrugs off cosmic rays without much trouble. But this thing was like a spotlight that burned through the blinds. For a few moments, our planet's electrical skin twitched under the stress. The fact that we are still here to talk about it is both lucky and mildly insulting to how fragile our situation actually is. As if those episodes were not enough, in 2025, astronomers caught something even stranger, a gamma ray burst that did not behave like any before it. Instead of lasting seconds or minutes, this one stretched out for an entire day, repeating multiple times. It was like a cosmic drumbeat, pounding again and again on a schedule. Before the first blast even hit, telescopes picked up precursor X-rays 10 hours earlier, as if the star was warming up for the main event. That is like hearing the band tuning their instruments before they smash the guitars on stage. Then the real show began. The bursts came in intervals of about 2,225 seconds, or a little under an hour. 3 of them arrived neatly spaced apart, but then the 4th showed up at nearly 4 times that interval. The pattern hinted at some kind of rhythm, like the heart of a dying star beating irregularly. The whole spectacle took place less than 1 billion light-years away, which by cosmic standards counts as right in our neighborhood. It happened in a dusty galaxy, which caused the afterglow to appear unusually red. Imagine a cosmic flare filtered through smoke. That detail alone threw researchers off, because it suggested dust was playing tricks with the light. But the bursts themselves were still genuine. Naturally, explanations started flying around. Some proposed it was a new twist on stellar core collapse, where the star's death rattle was extended and periodic rather than a one-time outburst. Others thought it might be a tidal disruption event, where a star wanders too close to a black hole and gets shredded. That scenario is basically cosmic spaghetti making, stretching the star into ribbons and feeding it to the black hole. We have seen something like this before with Swift J144 plus 57. Another bizarre event that had bursts instead of a single blowout. The leading idea, however, is even stranger. Astronomers think it might be the first evidence of a white dwarf star being torn apart by an intermediate mass black hole. That is important because intermediate mass black holes are the missing link between the small ones, formed from stars, and the giant ones that anchor galaxies. We know they should exist, but catching them in action has been like trying to find Bigfoot in the fog. This burst may have given us a glimpse of one finally stretching its cosmic legs, and the periodic bursts could be the signature of the star being gobbled up in chunks, like the black hole taking repeated bites instead of swallowing all at once. So why not simpler explanations like dust echoes or gravitational lensing? With dust echoes, later bursts should appear weaker and softer, like a light fading behind curtains. But here, the later bursts actually grew brighter and harder. That breaks the dust model. Gravitational lensing would repeat the same burst shape exactly, since it is just a copy of the same signal bent by gravity. But these bursts were different each time, which rules that out too. Nature seems to be writing new rules on the fly. What this all means is that gamma-ray bursts are still not fully understood, even after decades of chasing them. They are not just random fireworks. They are clues to the most extreme physics in the universe. They tell us about how stars die, how black holes feed, and how matter behaves when it is pushed to the limits of what is physically possible. And every time we think we have figured them out, they hit us with another curveball, whether it is 17 minutes of double flashes, the boat-frying satellites, or an entire day of rhythmic blasts from a galaxy next door. The universe is not just stranger than we imagine, it is stranger than we can imagine. And gamma-ray bursts are its favorite way of reminding us. If one ever pointed at Earth, the atmosphere would be stripped away and the surface sterilized in seconds. That is not a scare tactic. That is physics. Luckily, the odds are so small that you are far more likely to be flattened by your own bad life choices than by a cosmic death beam. But knowing they exist, knowing they can happen at any time, is a reminder of how fragile our place really is. We orbit a star that will last billions of years, yet somewhere out there, stars are dying in ways that could erase whole planets in the blink of an eye. If that does not make you feel small, nothing will. Astronomers often describe gamma-ray bursts as cosmic laboratories, except the experiments are violent and nobody asked permission to run them. They are explosions so powerful They reset the scale of what you thought was possible. And the most frustrating part is that we are only beginning to understand them. Every new discovery pushes the boundaries of physics a little further, which is thrilling and horrifying at the same time. Think about the 2025 burst, the one that lasted a whole day. That was not just a new data point. It was a brand new category of event. Before that, the rulebook said bursts last seconds or minutes. Then, suddenly, here comes a burst that repeats for 24 hours, like it is daring us to rewrite the definitions. It is like nature tossing a brick through the classroom window just to see how confused everyone gets. This kind of event has implications beyond just gamma-ray bursts. If it really was a white dwarf being shredded by an intermediate mass black hole, then we are looking at direct evidence of a type of black hole that has eluded us for decades. Stellar mass black holes are easy. Supermassive black holes, no problem. But the ones in between, the Goldilocks variety, have been slippery. Finding them is like finding the missing evolutionary link between apes and humans. The 2025 event could be the smoking gun, except the smoke is made of X-rays and gamma rays that can fry electronics across light years. The periodic nature of the bursts also teases something new about how black holes feed. Normally, we picture them as bottomless pits, swallowing anything unlucky enough to cross the event horizon. But what if they can nibble instead of gorge? What if they can take repeated bites of a star, spitting out blasts of energy each time? That is the kind of behavior this burst suggests. It makes black holes sound less like vacuum cleaners and more like messy eaters at a cosmic buffet, tearing off chunks and leaving crumbs in the form of gamma rays. Of course, not everyone is ready to accept that theory. Science thrives on skepticism. Some astronomers argue that we might be seeing a variant of known processes, just stretched or twisted by unusual conditions. Maybe the core collapse of a star that spun too fast, or a tidal disruption event with peculiar timing. The problem is, none of the existing models fit neatly. It is like trying to explain a new animal by calling it a weird dog, when in fact it might be a brand new species. The safe bet is that we have not seen the full range of cosmic disasters yet, and this is just the latest reminder. The difficulty of studying gamma-ray bursts also makes them maddening. They arrive without warning, they vanish quickly, and they come from billions of light years away. Imagine trying to study lightning, except the strikes happen once every few months, somewhere random on Earth, and the only tools you have are binoculars. That is basically what astronomers are dealing with, which is why every new burst, especially one as bizarre as the 2025 event, is treated like a gold mine. You grab every scrap of data before it fades, because once it is gone for good. Gamma-ray bursts also force us to rethink safety in space exploration. Right now, Earth's atmosphere acts as a shield, absorbing most of the radiation. But the moment humans start colonizing planets with thinner atmospheres, or living on space stations long term, GRBs stop being an abstract threat and start becoming a practical problem. A single burst in the wrong direction could fry electronics, strip atmospheres, and deliver lethal radiation doses. It is the kind of risk you cannot engineer away easily. You just have to hope the cosmic dice keep rolling in your favor. Yet, despite the risks, there is a certain beauty in these bursts. They are violent, but they are also informative. They shine a light, quite literally, on processes we could never recreate in laboratories. They teach us about extreme gravity, magnetic fields, and the behavior of matter under pressures that make atomic nuclei sweat. And each time we detect one, we are not just seeing a flash of energy, we are watching the death throes of stars and the birth cries of black holes. It is grim, but also poetic, the way destruction and creation are fused together. The boat in 2022 is a perfect example of that duality. On one hand, it was so bright it disabled satellites and shook Earth's ionosphere. On the other hand, it gave us a flood of data about how the most extreme bursts behave. It was like being blinded by fireworks, but still learning the chemistry of the sparks. The 2025 burst went even further, not just lighting up our instruments, but reshaping the way we think about GRBs entirely. Sometimes the most disruptive events are the ones that teach us the most, whether we like it or not. There is also the existential angle, the reminder that life on Earth is balanced on a knife edge. We worry about asteroids, climate change, and our own stupidity, but the universe has far scarier cards to play. A gamma ray burst close enough and aimed correctly would erase our species in seconds, without warning and without drama. No heroic space missions, no chance to build a bunker, just instant sterilization. That fragility is uncomfortable to sit with, but it also puts everything in perspective. The fact that we exist at all, in a universe where these things happen, is absurdly lucky. Astronomers are not in the business of comforting anyone, but they will tell you that the odds of a life-ending GRB are tiny. The beams are narrow, the galaxies are vast, and the chance alignment needed is rare. You are safer worrying about slipping in the shower. But the very existence of these bursts should remind us that nature is not tailored for our convenience. The universe is not a stage for human drama. It is a chaotic arena where stars explode, black holes feed, and planets occasionally get collateral damage. If anything, our survival so far is more surprising than the idea that one day we might not be so lucky. And maybe that is the deeper lesson of gamma ray bursts. They remind us that the universe is not here to be understood. It is here to be survived. We can decode the physics, map the patterns, and build theories about black holes chewing on white dwarfs. But in the end, we are ants watching bonfires. The scale is beyond us. The power is indifferent. And the only rational response is a mix of awe and humility. So the next time you feel important, remember that out there, somewhere, a star is dying so violently it could erase us all in less time than it takes to yawn, and the universe will not even notice we are gone.